Many friends have asked me about welding, whether to use tack welding, seam welding, or pulse welding. How to weld a bead that is strong, beautiful, and free from deformation. In this lesson, I'll share some welding tips with you. Preparation. We need to prepare the following items. First, a welding table. Besides, welding suit, safety goggles, mask, workpieces, and gloves. Step 1. Set the shielding gas in accordance with this table. For welding, you can use nitrogen or argon. Here I'm using nitrogen. Next, I'll show you how to check the actual gas pressure. First, select machine status. Then, press and hold the grip sensing button and trigger to allow gas flow. This value is the actual gas pressure. Step 2. Check whether the lens protector is dirty or damaged, which may decrease the output power and affect welding quality. Step 3. Ensure that the welding nozzle scale matches the recommended value in the system settings. On the touchscreen, tap System Settings and take down the value of focus scale reference. Open the fastener. Keep consistent with focus scale reference. Close the fastener. Step 4. Install the proper welding wire according to the table. The larger the weld seam, the larger the wire diameter needed. Also, check whether the wire material matches the workpiece according to this table. Step 5. Make sure the wire is installed in the groove of the welding head. Otherwise, reinstall it. Step 6. Before welding, you need to clean the weld seam. Clean off the oil and dust on the surface. You can clean it using cotton swabs or lint-free cloth with water or alcohol, grind it with a grinder, or use the cleaning nozzle to clean it. Clean the area to be welded to avoid affecting welding quality. After it dries, you can start welding. On the touchscreen, select the welding mode. There are 3 welding modes. Select Advanced Mode, and you can see the 3 welding modes. The first is seam welding. The second is pulse welding. The third is tack welding. Let's introduce tack welding. Tack welding is to use a brief burst of laser emission to weld at a specific point, creating small, dot-like welds. It's usually used before seam welding and pulse welding as a temporary fixing point. A fixing point, as the name suggests, fixes the workpieces together. For example, tack weld these 2 points first, then do seam welding. These 2 tack welds are the fixing points. Or for some thin items, for example, a 1 to 2 millimeter pentagram-shaped metal plate. To fix it onto this round plate, you need tack welding. Tack welding is very suitable for thin metal materials. Advantages: high precision, low deformation, and a neat appearance. Disadvantage: low load-bearing strength and not very firm. That's where tack welding is typically used. Next, we need to set tack welding parameters on the touchscreen. After confirming the parameters are correct, turn on Enable Lasering and perform tack welding. Next, I'll use the pentagram as an example for tack welding. First, roughly fix the position of the pentagram. Since tack welding doesn't require welding wire, so just align the welding head's red spot to the exact spot and start welding. We can also demonstrate tack welding with metal sheets. First, still align the welding head's red spot with the weld joint. Next, start welding. If blackened marks appear, wipe them clean with alcohol or water. After welding, don't forget to turn off Enable Lasering on the touchscreen to prevent accidental laser emission. We can see many settings available in tack welding mode, including parameters like laser power and spot duration. Adjust them based on welding experience. If you want stronger penetration in tack welding, you can increase the power value. If you want a nicer look and don't need it to be that strong, you can reduce the power value. Tack time is the same, you can increase or decrease it. You can also enter professional mode for finer parameter adjustments. Next, let's introduce seam welding. Seam welding is to use high-energy continuous laser beams to weld the workpiece continuously and evenly, thus forming a continuous, uninterrupted weld bead. Seam welding is widely used where high strength and heavy load bearing are required, or for airtight connections such as water pipe welding and automobile chassis crossbeam welding. Advantages: high weld quality, strong load capacity, no gas leakage, and no liquid leakage. Disadvantages: high cost, thin plates can be burned through easily, large heat-affected zone, and risk of deformation. Next, switch to seam welding mode. Use the default parameters. Turn on Enable Lasering and Enable Wire Feeding to start welding. Next, we'll demonstrate seam welding. Because seam welding has a large heat-affected zone, thermal expansion and contraction can easily occur. Therefore, when you need to weld a 90-degree angle, set the welding angle a bit larger, for example 100 degrees. Then the actual welded angle will be 90 degrees. Tack welding doesn't need this because the heat isn't enough to cause thermal expansion/contraction and angle error. Before seam welding, we need to tack the weld points. If the workpieces are long, it's recommended to add a few more fixing points in the middle. When welding fixing points, we don't need to switch to tack welding mode. We only need to turn off this switch on the welding head. Then the welding head won't keep feeding wire automatically. This allows quick switching between seam welding and tack welding. First, use tack welding to make the fixing points. When switching back to seam welding, remember to turn the switch back on. Then it will feed the wire automatically. Turn on the switch on the welding head. Before seam welding, be sure to check if the position is correct. You can still make fine adjustments at this time. After seam welding is finished, it can't be adjusted. Then weld from the start point to the end point without stopping midway. Do not let the wire deviate from the welding path. During welding, do not pull the welding head backward by hand, as the welding wire will automatically drive the welding head to move backward. Otherwise, it may cause weld breaks or uneven seam filling. If the welding result isn't good, you can adjust the welding parameters. For example, to make it more penetrative or stronger, we can increase the laser power. If you want less yellowing or blackening, you can reduce the power. You can also adjust the welding width. According to the actual welding needs, laser frequency and wire feeding speed can both be adjusted. For the impact of different parameters, refer to the link in the comments section. Next, we'll introduce pulse welding. A fish-scale weld bead is made by pulse welding. Pulse welding is to use pulsed laser beams to instantly melts the weld area and forms dot-shaped molten pools. Multiple dot-shaped molten pools overlap one after another, eventually forming a fish-scale weld bead. Pulse welding is mainly used for thin plates that need both adequate strength and low deformation. It is a transition process between tack welding and seam welding. Advantages: less deformation and stronger load-bearing performance. It can also handle highly reflective materials. The bead is attractive, needs no grinding, and suits irregular seams. Disadvantages: tiny gaps may exist, resulting in weaker sealing, and it is not as strong as seam welding. Next, switch to pulse welding mode. Use the default parameters. About pulse welding parameter adjustment, there is one thing to note. Since the fish scale appearance of pulse welding is related to the actual welding speed, the parameters above were adjusted based on a typical operating speed and are provided for reference. Enable lasering. Next, we'll demonstrate pulse welding. If you want welding without deformation, and you don't want to reserve extra angle space during positioning, pulse welding can also be done directly without adding wire, so you don't need to consider thermal expansion and contraction. This simplifies the process, and the remaining steps are the same as seam welding. After welding, you can check the backside. If there are no marks or deformation on the back, the weld is successful. Next are general welding tips that apply to any mode. First, do not weld directly on the welding table. Otherwise, the workpiece may get welded onto the table and be impossible to remove. The weld area must be raised off the table. Second, the welding nozzle should be at a 45-degree angle to the seam. It shouldn't be too high or too low, otherwise the success rate will drop. Third, aim the welding head at the workpiece. Make the wire tip touch the workpiece, and the red spot fall on the weld position. Then hold the grip sensing button and trigger to start welding. Fourth, lift the welding head immediately after finishing to prevent wire sticking. If the welding wire sticks to the workpiece, do not pull the welding head hard or shake it left and right. This will bend the wire and affect the next weld quality. The correct method is to turn off the wire feeding enable switch on the welding head, then fire the laser once more while lifting the welding head. Fifth, if high hardness isn't required and you want a nice seam without black edges, in settings you can reduce the material thickness by 1 to 2 millimeters. For example, if the plate is 2 millimeters thick, choose 1 millimeter. This makes the seam bright with no black edges. If black edges already appear, use the cleaning nozzle to clean it. Sixth, if there is no laser output during welding, it is very likely because the safety interlock loop is not closed or enable lasering is not turned on. These are safety mechanisms designed to ensure safe welding.